Here in this video, we would like to derive an equation called ideal gas equation. First of all, what is an ideal gas? Let me tell you once. Ideal gas is somebody who obeys all gas laws like Boyle's law, Charles law, Avogadro laws at all temperatures and pressures. At all temperatures and pressures. So taking that into consideration, let us try to an equation for an ideal gas. Let us consider an ideal gas in a container like this. Let it has an initial pressure P1, initial volume V1, initial temperature T1. That's an ideal gas that we have taken. Now we are making a little transformation. The same ideal gas, we are keeping the temperature fixed at T1 itself. That we are changing the pressure to a different value P1 dash. Volume automatically changes to a value something like V2. So in this case, as temperature is kept constant, we can apply Boyle's law. As per Boyle's law, at constant temperature, pressure is inversely proportional to volume, or pressure into volume equal to constant. That implies pressure into volume in the first case is P1 V1. Pressure into volume in the second case is P1 dash V2. From here I can get P1 dash equal to P1 V1 by V2. That's the first part. Now let us go to the next step. The next step, we will continue with the same gas. Earlier we have kept temperature constant. Now we keep volume constant and change the temperature from T1 to T2. Automatically pressure also changes. Let it has changed from P1 dash to P2. So what we can say here, as V2 is kept constant as per Charles law, Boyle's law and Charles law has to be valid because you are talking about an ideal gas. As per Charles law, what we can say is pressure is directly proportional to absolute temperature. That implies P1 by P2. P1 is P1 dash here. P2 is P2 here, equal to T1 by T2. T1 is initial temperature, absolute. T2 is final temperature. From here I can write P1 dash as P2 T1 by T2. If you notice, in the first equation on LHS side we have P1 dash. Now in the second equation also on the left hand side we are having P1 dash. As both LHS are equal, equation number 1 equal to equation number 2. What happens in that case if equation number 1 equal to equation number 2? We can continue further and write from the equation number 1, P1 V1 by V2 equal to, from equation number 2, P2 T1 by T2. Let us take all ones to one side, P1 V1, get the T1 to this side, numerator will come to the denominator. Take this V2 to that side, denominator will go to the numerator, P2 V2 by T2. So even if you move to a number of the stages, we will get PV by T is equal to constant. As you are talking about a gas of 1 mole, for a gas of 1 mole, we can say PV by T is constant and that constant is called capital R, where this constant capital R is called universal gas constant. The name itself tells you that it is constant for all the gases across the universe. It is same for everywhere. So, but that is when for 1 mole of a gas, right? I can write for n moles of gas, I can write PV by T equal to not just 1 R but n R, where n is number of moles, which can be further written as mass of the gas by molecular weight of the gas. So N can be written like mass by molecular weight. That implies what we have got is PV by T equal to NR. That implies PV equal to nRT. That equation, PV equal to nRT, is an equation called ideal gas equation. So in ideal gas equation, P is pressure, V is volume, N is number of moles, T is absolute temperature. Be careful, it's not temperature in centigrade, but absolute temperature in Kelvin. R is called universal gas constant. I will talk about universal gas constant in a separate video and derive an equation for that value and the units. I will talk about the dimensional formulas in the other video. But now I'm just leaving it as is. I just will write one more small thing. I will just continue writing one more small thing. You got PV by T equal to constant. You know, density is equal to mass by volume. We want to eliminate volume now. So in the place of volume, we can write mass by density. It implies P by T. In the place of volume, I can write mass by density equal to constant. Anyway, mass for a given gas is already constant. So pressure by density and absolute temperature is constant by mass. That is also a different constant. So P by dt is constant. That means if you want a relation in terms of pressure, density and temperature, P1 by D1 T1 equal to P2 by D2 T2 can also be taken while we are solving some of the problems. This is also a conclusion of a ideal gas equation. So ideal gas equation is this: P1 V1 by T1 equal to P2 V2 by T2, or PV by T equal to constant. This can be used to solve so many problems. This will give you a relation between three parameters that are varying with a gas, that is pressure, volume and temperature. That's it. Next video I will be talking about that universal gas constant itself separately. Thank you for watching.